with Brett Steudle. I hope I'm saying that correctly. He's an account executive for utilities at ChargerHelp. In July of 2023, in his role, Brett is focused on developing business opportunities with electric utilities across the country. Prior to joining ChargerHelp, Brett spent over 4 years at DTE Energy, an electric utility provider in Detroit, Michigan. In his time there, Brett was deeply involved in the regulatory process and launched several EV programs. Some of Brett's main accomplishments at DTE include securing $11 million of federal funding for DTE to own and operate the state of Michigan's first electric truck stop, developing and launching a residential EV charger installation program, and obtaining regulatory approval for over $25 million for utility EV programs. Prior to DTE, Brett spent 7 years at NASEO Cabinetry, where he was in several financial and strategy roles. Brett holds a Bachelor of Arts degree from the University of Michigan and a Master's of Business Administration with a concentration in finance from Oakland University, the team that blew up your brackets in the NC2As. So Brett, I'll just introduce the speakers individually as they come on, Robert. So let's hear from Brett now.
Yeah, thanks. Appreciate the intro and for you all having me here today. So I'm here to represent ChargerHelp. I joined the company in July, and we've seen a tremendous amount of change just in that amount of time. If you go to the next slide here, just kind of gives an intro to ChargerHelp. We are an EV charging reliability company, founded in 2020 with really the goal of bringing data and insight into the reliability issues that were going on in the EV industry, and really to do this kind of across the board, no matter what the hardware or software on the charger is, to bring that insight. We only do charger operations and maintenance. We don't sell chargers, we don't sell the software that goes on the chargers, and we don't install chargers. We're very focused on fixing chargers that are having issues in the ground. On the next slide here and the couple after, just to give you a little a sneak peek, we're actually going to be releasing either in April or May a reliability report that'll be available to the public. We have full-time EVSE technicians. They went out and did testing on almost 5,000 chargers out across the country, just to kind of at our own interest and wanting to get the insight into what was going on. And I can show you here on the next slide some things that we found that just give you a little bit of insight into what's going on with reliability of chargers. So if you focus just on the right bar there, 16% of chargers that we found had a dispute between what the charger was saying and what the app or online portal was saying. So if the charger was saying it was online, the app was saying it was offline, or vice versa. If the app said it was online, the charger actually showed up and it was offline and you couldn't actually use it. Not a good experience for either situation, and that's on top of the 15 to 20% that were completely out of service in both scenarios. And on the next slide, you can see that even the chargers that were online and available in the app, online and available at the charger when you looked at it, 1 out of 6 or 7 still didn't actually deliver a charge to a vehicle. So there was still something wrong, even though everything said that it was fine. And on the next slide, it goes into kind of what we've seen over the last 4 years, and as part of this assessment that we did, that it's about 30% of the chargers aren't functioning at any given time. And we've really identified 3 key reasons why that is happening. The first is misaligned solutions. So a lot of times the first reaction someone has when a charger is down is to send someone to the charger to fix it without doing any work up front to understand what is actually in the data of that charger, to be able to give you some insights before you send someone out to the charger, kind of, going in there blind to troubleshoot and then try and implement a fix. It leads to a lot of repeat trips and lost time. 70% of the problems that we see are actually failed software or data transactions. So it's a huge issue on networked chargers. It is definitely the vast majority of issues that we see. And it's because there are about 12 or 13 data handoffs that have to happen every single time a vehicle plugs into a smart charger for it to actually deliver a charge correctly to the vehicle. And then third is that data inaccuracy that I kind of went over a couple of slides ago, where there's just something says it's working, something says it's not working. You never quite know until you actually show up and plug in the vehicle, which is a really bad experience for EV drivers. And so at ChargerHelp, we have a solution that we call reliability as a service. And we pair our full-time EVSE technicians with technology. So we don't just have a team of technicians. We don't just have a technology in the background. We're really dependent on both of those things interacting together. So when our technicians go out to the field, they have insights from the 20,000 chargers that we've touched over the last 4 years, all of the issues that we've diagnosed and solved. They have access to all of that information at their fingertips. And then while they're there, they're also able to feed data back into our software so that we're constantly gaining data and understanding of what is going on with chargers in the field. And we consolidate that all into a platform that we call Empower that gives us and our customers a ton of insight for monitoring, managing, and reporting. We work a ton with utilities across the US, and this reporting piece of uptime and really granular data outside of just what the network is saying is super valuable for the customers that we have today. On the next slide, just want to talk about the EVSE technicians. So first and foremost, these are not electricians. They are technicians. It is a different job category. 97% of the problems that we've seen, again, we've worked on almost 20,000 chargers. 97% of the problems we've seen are non-electrical issues that do not require an electrician to actually fix them. 3% of the time there is something wrong upstream and electricians are needed. But 97% of the time, somebody with training in how to be a technician is able to actually complete that work. So we train on all of the major safety things that electricians train on. So OSHA, NFPA, high voltage training, lockout, tagout. We train for level 2 and DC fast charging. And then we do hands-on training for basically everything that a technician would do in the field, whether it's communications testing or troubleshooting, swapping out a level 2 charger, replacing parts, doing preventative maintenance, commissioning a charger. We really do a ton of hands-on training before our technicians are out in the field. And really exciting is that in about a month, the Society for Automotive Engineers, SAE International, they will be launching the first industry certification for EVSE technicians. We've partnered with them for about the last year and a half. Really, really excited for an industry certification to be out there. The EVITP certification that has been out there for electricians has been great for that sector of the market, but we're really, really looking forward to having an EVSE technician certification that individuals can get that certification and be able to go into the job market knowing that they've been trained and are able to do this job safely and effectively. And then I mentioned on the next slide, we have our technicians have access to an app on their phone or their tablet where they're able to access information and input information while they're in the field. We have, at any given time, we probably have 19 or 20 different unique things that are going on with chargers that we're responsible for. And sometimes it's 20 this month, and then there's another 10 and another same 10 next month. So we've identified about 30 to 40 different things that can happen with a charger and what causes it to go down. And what we've done is through this app, if a technician goes up to a specific charger, they're able to look through the workflow of what they're seeing and match that against a workflow that someone else, another technician at another point, has actually gone through all of those steps to get to a resolution, which we've seen it cuts down on the time that our technicians are on site pretty substantially, which has been great because our reliability as a service is an unlimited labor subscription, and so it is really behooves us to have our people out there as little as possible and do the job as quickly as possible when they're there. The next couple of slides are just a couple of snapshots from our Empower platform. Again, we use this internally a ton, and then our customers have access to it for really monitoring their network. And then on the next slide is the uptime reporting, and being able to look at by connector what the actual uptime is. And we call this really true uptime. It's not just the uptime of what the network is saying, because we've seen so many times where the network says the charger is working, but when you go to the charger, it's not working for whatever reason. Sometimes there's not even a cable that's on the charger. It's gotten ripped out, and the network is saying, yeah, you can pull up to the charger and charge, but you clearly cannot do that. So we are capturing not just that network data, but the field data to provide a true uptime metric that is inherently a little bit lower than what actually gets reported from the majority of the industry, because it's taking into account both factors there, the software and the actual in-field experience. On the next slide, just want to kind of give some insights and what we've found to date. We're constantly growing our database. We're working on about 250 chargers a month. As we continue to get better and collect that data and increase our efficiency, we actually have just been approaching 98% over the last couple of months. And it will just continue to get better here as time goes on and more data is fed into that system. And if you think about uptime, 97% gets thrown out a lot. In real terms, that means that a charger over the course of a calendar year can only be down for 11 days. And so if you have delays in people getting to the site or having to go multiple times, those days start to add up very, very quickly. So when we have our customers on reliability as a service, we typically are committing to either a 2, a 3, or a 5-day service level agreement, which means that our technician will be on site, usually with the resolution in hand, to get that charger working. And we've been able to deliver at almost a 50% reduction in what our commitments are to our customers. And then finally, I guess 2 more slides here, but the next slide is just kind of a list of all of the partners that we've worked with in the industry. We've touched pretty much every type of charger that is out there today. We work on I think 20 or so different hardwares at any given time, and have the network providers that are all out there as well. And then on the last slide that I've got for today is just really a snapshot of our team. They've got 40 years of experience at different parts of the industry, from EV Connect, which was one of the network providers that is out there, to our other co-founder is from the Department of Labor, Rivian, Tesla, McKinsey. We've built a great executive team that is able to drive a ton of insight into this industry and results for our customers. So I thank you again for having me. I think we're doing questions at the end, but happy to answer questions whenever anybody has any.
Yeah, we'll do questions at the end. Brett, I just did have one though in the meantime, because we have another couple of minutes here. It baffles me that you're going out and finding these issues, right? There's such a disparate sort of understanding, I guess, of what's actually happening versus what is reported. Isn't there some isn't the interface between on the ground and the actual vendor? Shouldn't it be more accurate? I mean, I came from the telecom industry. If there's a fault in the network, it's there. It's on the screen. They know it. Just how is that something that you troubleshoot as well, or what's happening there, that disconnect?
We do troubleshoot, and we provide feedback to the manufacturers and the networks that we work on for free. Like we say this is what we're seeing. We think it could be valuable. Just as an instance, we actually there was a very specific EV model when it plugged into a very specific EV DCFC that would not work. It was the only model that wouldn't work on the charger. And it was because there wasn't a firmware update in the charger that would allow that vehicle to charge. And so we are feeding information back to the industry when we're able to to make it be better. And it's also the technology on chargers is getting better. So there have started to be sensors in cables, for instance, right? And you can tell if a cable is cut, where a lot of the chargers that are out there today, you actually can't tell that. It doesn't throw a fault. One of the reasons that we've seen a big issue is that chargers can have anywhere between 30 and 35 error codes that are available. But a lot of times people only implement like 10 or 11 of them. So it leads to a lot of unknown errors that are happening because they're not, it takes more work and effort up front to actually implement all of those error codes across your entire system. And up until recently, the reliability portion of the industry was not a huge focus. Glad we're very, very happy that it has become a focus recently.
Great. Thank you so very much. And we'll have more questions for you afterward. Appreciate it so much. Thank you, Brett. So now we'll go to Jacob Matthews, Senior Advisor in the Standards and Reliability section within the Joint Office of Energy and Transportation. The systems focus on charging communication standards, interoperability, and charging system security and reliability. Prior to joining Joet, Jacob had a long career with Ford Motor Company, where he served as a manager of electrification and test technologies at Ford's sustainability homologation, I'm sorry that word, and compliance division in sustainability, the environment and safety engineering, responsible for developing advanced test methods, EVs. He regularly interfaced with external organizations, agencies, utilities, and policymakers to help shape regulations, standards, and policies for EV infrastructure that would promote EV adoption. He also served on the board of Charging Interface Initiative North America, Inc., and as a founding member to help promote consistent EV charging standards across North America. Additionally, Jacob has had over 25 years experience in product development, launching various product lines, including some early Ford EV products. He's a recipient of over 35 US patents, many in EV technologies. Jacob holds a Bachelor of Science degree in electrical engineering from Temple University and a Master of Science degree in electrical and computer controls engineering from Wayne State University. Jacob, we're so happy to have you and look forward to your presentation. Thank you so much.
Thank you, Commissioner DeWitt. I appreciate it. It's really nice to be with you all this afternoon. And I will simply add that electrification has been my passion for the past 2 decades. And so even though I was retired from Ford, I couldn't stay retired. I had to get back in the game. And so here I am now focusing on the infrastructure side, helping to make charging experiences better for our EV customers. So we go to the next slide, please. Just as you already know, the Joint Office of Energy and Transportation was created through the Bipartisan Infrastructure Law to facilitate collaboration between DOE and DOT. And the Joint Office helps to align resources across these 2 agencies to achieve leverage outcomes. Our mission at the Joint Office is to accelerate and provide transportation systems that are affordable, convenient, equitable, reliable, and safe. And it's in our vision that the future would be where everybody can ride and drive electric. Go to the next slide, please. So, all right, I'll take a quick moment and just talk about charging and interoperability and reliability. As you can tell from my background, having been in the automotive space, achieving reliability is very, very important. I mean, obviously, we have to make sure that our customers are able to go from point A to point B. And so similarly here, we're building the same kind of disciplines into the charging network. And so what you're seeing here is essentially 6 areas that we're focusing on. But starting from equity and cybersecurity as being one of the main components, we're looking at reliability, interoperability, data sharing, and of course, working with utilities. Clearly, if you are deploying a charging system that requires 600 kilowatts of minimum power to meet the minimum standard requirement along certain highways, that could be a huge challenge. Utilities are just not don't have the distribution network or the capacity in that location to deliver that. So we got to come up with solutions jointly. So we're definitely focused in these areas. And I can take a lot of time talking about all this, but I'll try to focus really on the topic of reliability piece. Go to the next slide, please. This kind of shows the areas that we're focused on. So our team, led by Sarah Heipel, we were focused on defining the standards that make up the CFR 680, but then also we work with Federal Highways to sort of help provide them technical guidance and any guidance that they provide to states and others, and helping to have seamless integration between various aspects of the ecosystem. We are developing an open source platform, and I'll just touch upon that very briefly in a few slides coming up. But then we've also commissioned national labs to develop what we call the ChargeX Consortium. And this is, again, the mission here is to look at all the different pain points that can occur and break down the reliability of the charging experience. So the ChargeX Consortium, and I'll talk about that a little bit more here in a few minutes, but it is laser focused in helping to define and improve the accessibility and the overall charging experience by underpinning it with activities and research and developing guidance that will help the overall industry. Additionally, at the Joint Office, we're also looking at data analytics, and you've all probably heard about EV Charge, which is a web-based centralized hub for submitting electric vehicle charging infrastructure data that's required under CFR 680-112. And this system actually launched last month, so we're really excited about that, and seeing how the data in this system can then be utilized to help further streamline and also provide information to the customers of the status of the network. And so that's an important task for us. And of course, we're also helping to develop what we call lab capacity to be able to validate, verify, ensure that the products, the charging systems are actually meeting all the standard requirements, et cetera. And we'll touch upon that in a little bit. So let's just go forward real quickly. Next slide. So this is a slide just summarizing our minimum standard. Clearly making sure that the charging experience is reliable. That the chargers are working when drivers need to use them, as we just heard about that, and drivers can easily find chargers. That's another important task. Finding chargers that are working is also important. And the drivers should not be able to have to use multiple apps. They should be able to pay with a single method or a streamlined method. And chargers need to support drivers' need well into the future. So that's just a very high-level summary of the minimum requirements that we have put forth in NEVI. I'll touch upon next our work with the Linux Foundation, and the objective here is to build awareness and buy-in of an open source reference architecture for the mobility ecosystem. That's kind of a mouthful, but essentially what it's saying is that, if you go to the next slide, we're looking at the overall ecosystem, and we can see which areas of that ecosystem, from an EV connecting to the charger connecting to other vehicles, or the back end, or the back end communicating to another subsystem back end. All these are interconnected systems that need to work together. And so we reached out to the industry, knowing this type of an ecosystem, to understand where the pain points might be and where the industry would need assistance, most assistance. And so the next slide sort of highlights the 4 major areas that we were looking at. Number 1 being a fully tested ISO 15118-2 SEC reference implementation. So essentially what that means is that we have taken Linux as a base programming language or operating system, and we've developed in there the Chargers communication controller, and it's a reference architecture. So anybody, and it's open source, so any new company or an existing company can download this reference architecture and just simply deploy it. They don't have to develop a reprogram this device or put a specification. We've already done that for them in this open source, if you will. And so they can deploy directly, or they can use it as a reference to compare to what they have. And our goal here is that by having these software solutions provided for all these different points in between of the ecosystem, that we will minimize the hurdles that normally can take place in translating data from one system to the other, and in the end, provide a reliable and robust solution for the end customer. Let's go to the next slide. All right, so now I'll dive a little bit more into the ChargeX consortium. Next slide. So here, our mission is pretty clear. It's to ensure that any driver of any EV can charge their vehicle first time and every time. It sounds simple, but as ChargerHelp would say, I mean, that's not the experience today. So we're aiming for a very high bar and wanting to make sure that charging is as simple or even not better than the gasoline refueling model that we have today. That's what we're comparing ourselves to. And so even things like plug and charge, where you simply plug in to your EV and the charging session begins, is a step above your fueling model, because you have to first authenticate yourself, swipe a credit card, select the type of fuel you want, and then the fueling can begin. So we're trying to make it even better and simpler. So simple vision is, everybody can charge first time and every time. And to do this, we have actually brought together members of the industry, and we have convened all parts of the ecosystem. And actually, right now, there are about 86 companies that are part of this consortium that are participating in various meetings and discussion groups on a weekly basis. And I will touch upon the three big groups here just coming up. So it's a big endeavor, but again, this is a whole of industry, and so again, industry-led, government-enabled, if you will. And our scope, of course, is to solve a complex problem by bringing everybody together. The next slide, we talk about the three distinct groups that we have. The first working group is defining the charging experience, and the goal here is to have performance indicators, set and validated targets that will help track our progress. And so these performance indicators are important because they will tell us where in the charging process or charging experience is there a biggest pain point. And so we've broken that down in segments, and each of those indicators will tell us where the issue is, and I'll touch upon that in the next slide coming up. The other group is working group number 2, that is focused entirely on reliability and usability triage. Reliability is expandable. Usability triage is we're looking at issues that are presently existing in the charging ecosystem, whether it's payment issues or communication issues or hardware issues. And the goal is to solve that as a collective, and then be able to provide some solutions that can be easily deployed and implemented by all concerned parties in that particular issue sphere, if you will. The third group that is looking at is scaling reliability, and so that is again through diagnostic data sharing and interoperability testing, where we are engaging labs to help develop these methods and develop some recommended best practices for that can be easily deployed and adopted by the charging community. So that's the goal for ChargeX. let's just dive down a little bit more. So let's go to the next slide. And so I'll give you a couple examples. There are lots of different areas here. So I was talking about KPIs. So if you think about the charging process, so the customer has to first find a charging location. So we have a metric KPI called mean location accuracy. So, how accurately can I find that the charger is available and where it's located, if it's working? And so that metric will tell us, how easily a customer can actually locate a charger. And then there's a metric called mean wait time. So, how long is the customer waiting to actually access a charger? And then, as you can see there, there's a charge start success time and a charge end time. So again, these are different KPIs that we have set up in here to help measure where the pain points are the customers are experiencing, where the metric is high and where there is low, and where there's need work to be done. And so that's kind of the vision of developing these KPIs. And the goal, of course, is to use that data then to be able to then improve and find solutions for where the issues might be. The next slide, let's look at that. This is looking at reliability. So I talked about 3 working groups. I'm just giving you one example from each working group because of time. So here's one for payment reliability. One of the things we found was that either their customers were not able to make payments, and so hence they were not able to charge. Now that's quite nerve-wracking if you are a customer trying to get some charge and the payment system is not allowing you to proceed further. And so our ChargeX team looked at that and developed a recommended practice that can be then adopted and deployed through all the network providers and charging station manufacturers to help improve the overall payment system reliability. Go to the next slide, please. Here's an example, if you will, of the adapter reliability and safety. So as you know, we're transitioning to J3400, the NACS connector. And so there's going to be vehicles that have either a NACS port or a charger that has a CCS connector, and a different vehicle will show up. And so then we need to have an adapter that's being developed. But adapters are generally not as reliable, but how do we improve its reliability? And how do we make sure that the adapters are locked and they're safe and they don't create any unintended consequences for using them? So there's a major effort that's underway right now with SAE as well as CharN and all the key stakeholders to figure out what are the areas that things can go wrong. And so we're adopting failure mode effects analysis. It's a tool that was used in the automotive quite a bit in other industries. And so we're utilizing these tools to help figure out where the issues might be and how to improve upon them in the design process so that the customers in the end will have a high reliable product even when using adapters. And safety, of course, is paramount. So we're focused on that extremely. Let's go to the next slide, please. So just giving you an idea of, our activities is just snippets. There are a lot more activities here, but data diagnostic sharing. So, we talked about earlier that a lot of times there are diagnostic data that has not been implemented. We're certainly looking to make sure that these diagnostic error codes have been implemented, but also we want them to be shared and made readily available. So if these are known to ChargerHelp, then they can simply be better prepared and plan for their visit to know exactly what they'll be replacing. They don't have to get there to discover what the issue is. This should be known right away. So again, developing these error codes and being able to share that across the ecosystem. So we again improve the reliability of the overall system and the charging experience. Next slide, please. All right, so this is just a high-level roadmap. What I simply want to point out here is that our task at the Joint Office is to get things done really, really quickly, speedily. So our efforts right now here are short term. We're trying to make sure that issues that have been discovered that are being studied right now, or solutions being developed, are tracking to be finished as quickly as possible so they can be implemented promptly. So that you can just see some of the tasks in the working group 1, 2, and 3, and how our roadmap is leading to getting a lot of these things resolved by the end of this year. Next slide. All right, so let me just get back into the reliability standard a bit more. So here's, we talked about our uptime requirements, and so FHWA's aim to address charger reliability was in threefolds, right? The first one was for increasing technical skills and qualifications, and certainly ChargerHelp is key ingredient to that. And then, of course, number 2 was requiring minimum uptime. And I was really pleased to see that nice 8% uptime that ChargerHelp was reporting. That's awesome. But again, these are minimum uptime requirements, and 11 days out of the year, if a charger is not working, that's simply not good. Even though it doesn't seem like a lot of days, but it is. For a customer who's not able to find a charger, that's a problem. So we've got minimum uptime requirements, and then also the duration of outage and error codes to be reported in 680-112. So that's Federal Highway's goal to have improved reliability was to have training, have metrics for reporting, and setting a high bar of 97%. Next slide, please. And so talking about NEVI uptime requirement, the final rule, as I said, talked about 97%. Section 680.116 was revised to clarify exclusions for uptime. Sometimes there were things that were excluded were maintenance times or natural disaster or vandalism, or if a charger had limited operation time, that was excluded from the calculation. Next slide. And again, we're defining the uptime that is at 97%, but it must provide, must be operational and deliver the required power 97% of the time in a given year. And it's considered a charging port is considered up when its hardware and software are both online, available for use or in use, and the charging port successfully delivers electricity in accordance to the minimum power requirements. And the minimum power levels are 150 kilowatts as the vehicle requests. So obviously the vehicle is going to request when it's hungry, thirsty, 150 kilowatts, and as it starts getting filled up, it's going to request a little bit less. But the charging port must deliver according to what the vehicle is asking for. So and it's considered up when it's delivering it, and when it's not delivering it, it's considered not meeting the requirement. Next slide, please.
So, and Jacob, just FYI, I think just a time check. I think we better wrap up so we make sure we get through all the presentations for questions, which I know are out there. Thank you so much.
Okay, yeah, thanks. So I won't bore you with that. This is like the formula for that. It's simply saying number of minutes, and then we subtract from it whatever minutes the charger is not available, and you get a fraction, and that's how you get the percentage. Next slide was simply showing that how this would be implemented is that the states and the recipients would be either directly inputting information into this on a quarterly basis or annual basis into EV chart, or they could be directing their charge point operators or their sub-suppliers to do the same on their behalf. So 2 different paths, but either way, data gets into EV chart, which then would be then made available to the customer. So anyways, this is just reporting the same exact thing that I talked about. I think that's the end of my presentation, so I'll pause and I'll happy to take questions afterwards.
Thank you so very much, Jacob. Appreciate that, and we'll take questions afterward, as you said. So thanks again, and we'll move on to Jessie Lund. And Jessie joined NASEO earlier this month as NASEO's Clean Transportation Transportation Program Director, where she works with states on a variety of transportation policy and program issues, including electric vehicles, charging infrastructure, incentive programs, freight decarbonization, battery and vehicle manufacturing, economic development, workforce development, fuel cell vehicles, hydrogen refueling, and other alternative fuels. Prior to joining NASEO, Jessie worked on freight efficiency and decarbonization, municipal and state policy and climate action, and sustainability with CalSTART, the North American Council for Freight Efficiency, Rocky Mountain Institute, and the City and County of Denver, Colorado. Jessie, thank you so much for joining us and look forward to your presentation.
Yeah, thanks for having me. And thank you, Jacob, for that excellent tee up. That's actually the perfect handoff as we start to think about how states are thinking about reliability, much less reporting on it into the system that Jacob mentioned. So before I dive into what states are doing, just a quick overview of who NASEO is for those of you who may not be familiar. I've been getting pretty good at my elevator pitch over the last 3 weeks. But for those not familiar with NASEO, we are the National Nonprofit Association for the governor-designated energy officials from each of the 56 states and territories. Basically, we facilitate peer learning among state energy offices. We serve as a resource for the state energy offices, and we advocate on their behalf to Congress and federal agencies. Clearly a fan of collaboration. We also, I understand, have collaborated a lot historically with NARUC, so very excited to be here. And we also collaborate very closely with AASHTO, the American Association of State Highway and Transportation Officials. In fact, we, a couple of years ago, signed a MOU with AASHTO and the Joint Office to provide a framework of coordination between key state and federal agencies to ensure that these EV investments are made in a strategic, coordinated, and equitable manner. So that's a lot of what I'm going to talk about today, is what we've been up to for the past 2 years, what we've heard from states, and where they're at today, specifically with NEVI, but we'll talk a little bit broader as well. So we can go ahead and go to the next slide. I'm going to jump into a couple state examples, but what you're going to hear from both of these, if you take away anything from what states are doing, basically 2 things. They're trying to be as proactive as possible when they're selecting recipients for NEVI funding to ensure that they're essentially capable of delivering on these high uptime requirements. And then they're also kind of holding collateral, kind of this way to ensure that these awardees that they select are in fact delivering on those high uptime requirements. So that said, first I'm going to talk a little bit about what Alaska is doing. The Alaska Energy Authority, who is the entity that leads the NEVI program in Alaska, the governor there designated AEA as the lead agency in 2022, since the Energy Office had previously been tasked with minimizing barriers to EV adoption and administering infrastructure programs related to EVs in the state. The governor also signed an MOU between AEA and the Alaska Department of Transportation and Public Facilities in order to facilitate coordination on NEVI and statewide EV infrastructure investments. So as the NEVI lead, AEA issued an RFA, a request for application, last March for the first round of the NEVI program in the state. And as part of this application, the RFA required applicants to provide what they called an experience and qualifications narrative to ensure that applicants could meet the uptime and performance standards and comply with NEVI guidance and statutory requirements. What does that mean exactly? Basically, the narrative required that the applicant's project manager list their relevant qualifications, experience, that they describe their experience administering Title 23 federal programs in particular, which many states have expressed has been an issue with some proposals. They need to include resumes of key personnel, and then also previous experience with charger design and installation. So they had to include 3 to 5 reference projects for EVSE or charger installation by the contractor performing the work. And the projects had to identify the client, the contract value, number, and type of charging stations involved, and contact information for AEA to contact so they could reach out and actually hear from that project themselves. How are these chargers performing? What does uptime look like? And they're also able to cross-reference historical uptime reported in proposals with public data available on the PlugShare app. Every station gets a score. Uptime is included in that score, so they're able to check, make sure that their historical projects have been at least relatively successful. And if the previous project had any charging reliability issues, that would be identified in that application review phase. For Alaska, another factor in scoring proposals was whether the applications addressed Alaska-specific challenges, such as harsh winter weather, that are factors that could impact charging reliability. So we are seeing some states kind of tailor these applications to their needs to ensure that any applicants are aware of and capable of responding to state-specific needs that might inform reliability. In terms of monitoring reliability for contracted projects, AEA will retain a certain percentage of the total awarded amount to be dispersed over 5 years, given satisfactory performance. They will track the reliability and performance of the chargers by looking at the uptime data that's required by NEVI. That's what the data that will be uploaded into EV Chart that we just heard about. And we can go ahead and go to the next slide. That about covers it for what Alaska is doing. We're going to turn our attention to Colorado, where they are taking a very similar approach. In Colorado, the State Energy Office, who's leading the NEVI program in close coordination with the Colorado Department of Transportation, they have already issued their first RFA for NEVI. They call the program their Plazas program, but it does include NEVI funding. And as part of that Plazas program, they require applicants to submit a station maintenance plan that includes a summary of planned maintenance activities, including preventative maintenance by frequency and a communication strategy to keep the Colorado Energy Office informed about operations and maintenance activities. They also require applicants to specifically address the reliability of the equipment being proposed and how the applicant will ensure the ongoing operability of the station. And if anyone other than the applicant will own, operate, or maintain the site and equipment, for example, maybe they're going to work with ChargerHelp, then they need to provide a clear description of the roles and responsibilities of each party so that it's clear who's doing what. As far as station reliability, they require applicants to detail past experience and technical capability of managing reliable EV chargers as well, so very similar to what we saw in Alaska. They're also requiring applicants to describe the equipment warranty and provisions that help ensure the reliability and role of customer service and associated customer service number to address issues that might come up and other strategies to ensure reliability. And then as far as monitoring that uptime and reliability, each project is eligible for 95% reimbursement upon completion of construction and opening of that charger to the public. But the Colorado Energy Office does retain 5% of the total grant award, distributing 1% annually each year from completion of the awarded project, based on the grantee's timely completion of reporting and meeting those required uptime and continuous operation guidance, KPIs that we talked about earlier. That kind of covers the specifics that we're seeing from states with respect to NEVI, but I do want to just touch on briefly, we're also seeing some broader efforts at the state level. Thank you for switching the slide. I'm going to talk briefly about what California has been up to. So in 2022, the California Energy Commission was directed by the state legislature to assess the number of EV chargers necessary to support the state's EV adoption goals. And in doing this, the commission needed to assess the number of both public and privately owned chargers, as well as the reliability of those existing chargers to make an informed estimate on the additional number that they would need. Similarly, the CEC was also tasked to develop EV charger uptime record keeping and reporting standards for charging stations that received an incentive from either a state agency or through a charge on ratepayers that are installed on or after January 1st of this year, 2024. And then finally, beginning in 2025, the CEC must deliver biennial assessments of the reliability of both public and privately funded charging infrastructure. So no small task. given this directive from the legislature, the CEC pointed out that they currently lack the data to determine the reliability of public and private charging in the state. Oh, Carrie, I think you're not on mute. Thank you.
Sorry.
No
Just
problem.
getting into my car.
I just want to make sure you didn't have a question. Thank you. So just quickly back to the CEC. I'll wrap us up here in a second, but they didn't have the data that they needed to assess reliability of public and private infrastructure. So they have proposed a series of reporting regulations that would allow them to access this data. They developed a draft report this past September that highlights the proposed regulations and surveys the potential causes of reliability issues related to EV charging, as well as the need for additional data. Some quick examples of the proposed reporting requirements are they are looking for utilization reporting, such as the average hours per day the charger is used and when it's pulling power during this period. They're also looking at reliability requirements such as uptime percentage rate and minutes of excluded downtime, of course, in accordance with NEVI guidelines. Also charger operative status and charging attempts, such as successful charge attempts, failed charge attempts, and the percent of successful charges relative to total attempts. So good news is very in line with what the ChargeX consortium is looking at. The draft report received numerous comments, as well as some concerns from the industry on the proposed reporting requirements. One example I'll highlight is the EV Charging Association, which represents major charging providers and OEMs, folks like ChargePoint, Blink, ABB, Tesla. Some of the concerns that they pointed out is they are in opposition to the public disclosure of utilization data that might expose confidential business information and sensitive customer activity data. And so to address that, they recommended this practice only be used for publicly funded charging stations. They also recommended that the CEC make uptime data confidential on a per port basis, and any public disclosure of uptime or charge success data be aggregated on a statewide level. And then they also recommended that inventory data, such as address, serial number, charger ID, have the option to report granular data on an aggregated basis. We're now just waiting to see what the final rule that CEC puts out will be, but just to give you a sense of what is happening at the state level and how it impacts programs like NEVI, as well as potentially some other chargers that some states may be collecting reliability data on. And I know we're short on time, so I will end it there, but as everyone said, open to questions. And I will also note I've got a couple of my colleagues on the line today. I have been here 3 weeks today, so if I need help answering any of your questions, we've got the full team on deck. Thank you so much for your time.
Jesse, you did a great job 3 weeks in. Congratulations.
Thank you. Thank you.
And yeah, let's jump right into questions. We're a little bit behind, but hopefully we can have some really targeted questions and some targeted answers as well. So Robert, I can't see the hands raised, so maybe you'll sort of administer the Q&A if you would, please.
Sure. It's probably, I'm not seeing any in the chat yet, but feel free to please state your name, your organization. If you could also change your title to reflect that, and then the floor is open for whoever wants to go first.
So while we're waiting for others, I mean, I'll go first if I have. I guess this is to Jacob, maybe to everyone. The goal of having this replicable, I guess, experience at the EV charging station, replicable in that it attempts to mirror what people are used to at the gas station now. I mean, that seems like the intuitive way to move things forward. I guess I'm just wondering, is that how far are we away from that? How is that a realistic goal? Is that a stretch vision, or will we exceed that? I just kind of want to put that in, think about that and how realistic it is, because I think it's a great way to go. Just can we get there?
Yeah, I think it's a great question. I think so that is a minimum standard, right? So I think we need to shoot higher than that. in order to compete with the gasoline refueling model. But in order to get there, I think what we're trying to do from the joint office is to streamline the activities so that the implementation of software and the way data is communicated, and the way even the standard, the way it's written and interpreted, and there are just issues in the standard itself. All those things have to be resolved in order that the implementation can be as uniform as possible. From my personal experience and working in the EV segment for a while, you took a standard, let's say the 7072, and part of the interoperability issues that led to poor reliability was just the fact that it was implemented differently from one OEM, one EVSE company to the next. And so the interpretation of all that would then lead to a variation in experience. And so the things that we're trying to do is to also encourage lots of testing. And so we're actually starting up, working with Charin, for example, where we'll be helping to do some interop testing and setting the test cases up for the industry to check against. So as we come together and do all this work and streamline, I think that will lead us to having a more defined and a uniform implementation, which will lead to. So to your question, we want to get there? We're not there yet, but our hope is that if we're shoring up all these different issues that lead to non-reliable system or interaction, that once we resolve that, it will get to a higher reliability. And I think case in point is that if a company owns both the vehicle and the charging network, that system works better because there's all this interaction has been boiled down to to making sure that the production of vehicle and the charging system all work together. And because presently there is a fragmentation of all that, we see not so consistent behavior. So again, the goal is that from our joint office perspective is to hone in as to areas that will yield the best result, the biggest bang for the buck, the lowest hanging fruit, resolve those issues, and then that will dramatically improve our overall reliability. That's our goal.
Thank you so much. Others with questions? Well,
Al Freeman has a question.
okay.
Go ahead, Al.
Al, are you on for a question? If not, Robert, is anybody else in the queue?
Not that I can see.
Okay. Well, I'll take another one if I could then, please.
Sure.
Okay, we're at the stage, we're at midlife, I guess you would say, of many of these charging stations. And I know Brett said this was really a software issue, and it sounds like Jessie and Jake were talking about sort of where we're going with standards for new charging equipment and for software. But I mean, are we running into the issue of having chargers now reach midlife and problems that are unique, in that? And is that, I mean, are those things that are going to be, remedial, I guess, or be able to be remediated? Or does that just create a sustaining problem? If that question makes sense, anybody can take it.
Yeah, I can jump on that for a little bit, and ChargerHelp definitely would have lots of point on this as well. But there are, of course, components within the charging equipment that obviously will, could fail sooner than others. And so if these chargers are being used on a daily basis, things like contactors or connectors, and of course the cable, not the cable per se, but the port itself could get damaged and wear out. So those things will lead to non-reliable performance. But again, I think in having the minimum error codes that we're working with the industry on right now is to be able to pinpoint and do some diagnostics, self-assessment, if you will, to triage some of these issues that can occur. And so then before the customer discovers them, or soon after they're discovered, they're immediately taken care of. So some of these things are could be approaching midlife, but other electronics, other pieces, if they're designed correctly, could last quite a bit longer. And our goal, of course, was that any software update should be able to be done either over the air or through a connection by a ChargerHelp technician, just updating the software, but again being made available in a manner that can be dispatched quickly. So I think there are some of that some pieces that will evolve and develop over time. Software updates, as perhaps as things are discovered in operation, then there are improvements put in place, or if there are cybersecurity issues that are being discovered, then some patches are being put in place to fix that. But those things will evolve. But then, of course, some electromechanical parts, they should be able to be replaced if they are found to be faulty, even though they are approaching half or midlife, if you will.
Yeah, I would agree with that. I think one of the things that we've found is that a lot of the RFPs that have gone out for installing chargers, and whether it's utility or government, whatever it is, there are some times where there are requirements that aren't being put into place, where if they were put in place up front, it actually might solve a lot of these issues. So if you think about a network charger, there's 3 ways you can actually connect that charger to a network. You can do it over cellular, you can do it over Wi-Fi, or you can hardwire it. Hardwiring it solves a lot of issues. It just costs a little bit more money up front. And so that's usually not the option. But as we all know, Wi-Fi and cellular connectivity can be spotty. We run into situations where someone has called us a year after a charger was installed. It has never worked, and it will never work because it was installed. It's only capable of being connected to a cellular network, and there is not a cellular network there. So like those types of things being built into the that funding up front will help solve a lot of this, and a lot of it's being worked out with kind of the older chargers, and finding solutions. But anything that's cellular or Wi-Fi, even going forward, still poses a bit of a problem in terms of that critical piece of the data transfer, unless the chargers have the capability of, in the event that there is no network, that they're still able to actually dispense energy, which is a great solution as well.
Okay, thank you very much.